So we've looked at angles quite a lot so far, but we now need to start having a look at shapes. And we're going to start looking at shapes by looking at the 2D shapes. Now 2D is short for two-dimensional. And a dimension is just a fancy way of saying something that we can measure. So two-dimensional shapes mean that there are two ways we can measure them. As in, we can measure them across and we can measure them up and down. We can give them length and height, if you like, or width and height. Whatever you want to call them, it doesn't really matter. There are two directions that we can measure them in, across and up and down. And there are various shapes that we need to know about. Some of these you need to know quite a lot about, some of them we don't need to know quite so much about. And some of these will already be familiar to you, but it's worth brushing up on them once again. So we're going to go through the shapes one at a time. We're going to work out what we need to know about each one. And we're going to start with a square. Now a square has four sides, and the key thing about those four sides is that they are all the same length. Now we can state that those four sides are all the same length, or we can show this visually using a bit of handy notation that we do need to be aware of. So we've already seen how parallel lines we can label using arrowheads, while lines that are the same length we can show using dashes. So I'm going to put a short dash on each of those four sides, and the dashed lines are all the same length. So all four of those lines get a dash because they're all the same length. And if you see lines that are dashed in this kind of way, it means that they are the same length as any other dashed line. A square also has four angles, and the four angles are all the same size. In particular, they are all four of them right angles, so I've labelled them with the right angle notation, the little box in each corner. So four sides all the same length, four angles all the same size, and the angles are all 90-degree right angles. I can also pick up on the lines of symmetry for a square. Well, lines of symmetry wise, we have got top to bottom, a vertical line there. We've also got horizontal through the middle like that. But there are two more for a square as well. It turns out with a square that we also have the two diagonals. If we were to take a square and fold it in half along those diagonals, we would get symmetrical halves.
Here we have a square, and I have marked on one of the diagonals. If I now take this square and I fold it in half along that diagonal, then I should find that the two halves of the square, well, they should join up. There we go. They do indeed join up. They are the same size. Notice that one fits exactly over the top of the other. They are the same size. And in fact, they are mirror images of each other. If I hold it up this way, we see that the two are equal and opposite, in fact. So that is indeed a line of symmetry.
So overall, the square has four lines of symmetry. We could also talk about the square's rotational symmetry as well. If we were to pick up that square, turn it through a full 360-degree turn, it would fit over itself 4 times exactly. And so we say it has rotational symmetry order 4. Now, closely related to the square is the next of the shapes we're going to have a look at, and that is the rectangle. Now, a rectangle, like a square, has 4 sides, but this time the sides are not all the same length. We have 2 pairs of sides the same length. You'll notice this time that I have dashed the 2 short sides with a single dash, and I have double dashed the 2 long sides. It's still the same notation, the idea being that the single dashed sides pair up and are the same length, the double dashed sides pair up and they are the same length. So we have 2 pairs of sides the same length, i.e. 2 short sides, 2 long sides. And once again, we have 4 angles. The angles are all the same size, and they are, again, 4 right angles, 90 degrees. So I've used the notation there. Lines of symmetry, well, we can go top to bottom again, and we can go left to right. Turns out that that is it, and there are just the 2 lines of symmetry. There are no diagonals this time. Let's see why.
So I have a rectangle, and I have marked the diagonal on there. If I were to now fold this rectangle along the diagonal, I'm going to do it backwards on itself so that you can see that I'm folding along the diagonal. It doesn't line up. The shape does not line up when I fold along the diagonal. The two pieces are exactly the same size, but they are not mirrored, and if I were to hold the shape up like that, to see a vertical line of symmetry, it's easier to see that the two shapes are not mirror images of each other, therefore it is not a line of symmetry.
And again, we could make note of the rotational symmetry, and we would find that it has rotational symmetry order 2, once when the shape is upside down and once when it's back to where it started. So the square and the rectangle are perhaps the two classic shapes that everybody is probably reasonably familiar with. But there are more shapes that we need to know about. We also need to know about triangles. Now there are different types of triangle, but all triangles have 3 sides. In fact, tri as a prefix on words means 3. Think about a tricycle. A tricycle has 3 wheels. So a triangle has, well, in fact, 3 angles. And if it has 3 angles, then it will have 3 sides. So 3 sides and 3 angles. And we've already seen that there is something special about those 3 angles, because the angles in any triangle will add up to 180 degrees in any triangle at all. There are, however, 3 types of triangle. The first type of triangle is a triangle that looks like this, and it is called an equilateral triangle. Now, an equilateral triangle has 3 sides, but those 3 sides are all the same length. So again, we've got the 3 dashes on there to show that. So this is the first kind of triangle, the triangle in which all 3 sides are the same length, and if we have that, we have an equilateral triangle. Now, if all 3 sides are the same length, the connection between any pair of sides will be the same, and in fact all 3 angles will be the same size. Now that means we can work out how big each one will be. Because if we have 3 angles that are the same size, and they add up to 180 degrees, we can work out the size of one angle by doing 180 degrees divided by 3 to give us 60-degree angles for each one. And all 3 of those angles are 60 degrees. So if we have a triangle that has 3 60-degree angles, we must also have an equilateral triangle. So equilateral triangle, 3 sides the same length, 3 angles the same size, and those 3 angles are 60 degrees each. Lines of symmetry, well, we've got top to bottom, but bear in mind that this is the same triangle any way around, so we could just rotate it and make one of the other sides the bottom, in which case we will also have this line of symmetry, where the right-hand sloping side is now the bottom, or we could make the left-hand sloping side the bottom, and we'd have this line of symmetry as well. So there are 3 lines of symmetry in this triangle. Rotational symmetry, well, if we did that with a piece of tracing paper, we would find that it has rotational symmetry order 3 for an equilateral triangle. And that's the first kind of triangle. They're quite neat equilateral triangles. Everything's the same, 3 angles the same, 3 sides the same. It all kind of works out nicely. But then there's the second kind of triangle. And the second kind of triangle is one that looks like this. And this is an isosceles triangle. An isosceles triangle has 3 sides, again, because it's a kind of triangle, but this time 2 of the sides are the same length. In this case, it happens to be the 2 tall sides heading upwards. It might be a shallower kind of thing, but 2 of the sides have to be the same length. Now, if 2 of the sides are the same length, then 2 of the angles will be the same size. Which 2? Well, there is a very particular way of working out which 2 angles are the same size on an isosceles triangle.
To work out which 2 angles on an isosceles triangle will be the same, step 1, point to the 2 sides that are the same. Step 2, point to the angle where they meet. Step 3, the other 2 angles are the same size.
So on this particular triangle, as we've just seen, we point to the 2 sides that are the same. The angle right at the top there is the one where they meet. The other 2 then, so the 2 on the bottom marked in blue here, are the same size as each other. The other one, something else. Lines of symmetry, well, in this case, we've just got straight down the top from top to bottom. So we just have the one line of symmetry, and that's true of most isosceles triangles. Rotational symmetry, not really anything particularly interesting about rotational symmetry for an isosceles triangle. It's just 1 when it's back to where it started. So I'm not even going to bother writing that down. It's not particularly interesting. But if you did want to write it down, rotational symmetry order 1. So we've seen 2 kinds of triangle already. We've seen the triangle where all 3 sides are the same. We've seen the triangle where 2 of the sides are the same. And then, in fact, there is the 3rd kind of triangle. And the 3rd kind of triangle is the one that you are most likely to forget the name of. And the 3rd kind of triangle is the Scalene Triangle. The Scalene Triangle, once again, has 3 sides, but there is nothing special about those 3 sides. In fact, all 3 sides are different lengths, and all 3 angles are different. The angles still add up to 180 degrees, because the angles in any triangle add to 180 degrees. But all the sides are different lengths, and all those angles are different sizes. Lines of symmetry, probably none if they are all different. Rotational symmetry, probably just 1. Now there is one more kind of triangle that we need to be aware of. They are the 3 types of triangle, but there is a special case of triangle. This is not a type of triangle, it's a special case. But some triangles will contain right angles, and we say that they are right-angled triangles. It's funny that, isn't it? Right-angled triangles have 3 sides like any other triangle. They have 1 right angle and 2 others. Now a right-angled triangle can either be isosceles, as in 190-degree angle and then 2 others that are the same, i.e. 45 each. Or they could be scalene. So we could have a 90-degree and then say a 40 and a 50-degree angle. Can a right-angled triangle ever be equilateral? Well, no, of course not, because an equilateral triangle has to have 3 angles that are the same, and they have to be 60 degrees each. So a right-angled triangle, not a kind of triangle on its own, but we can have an isosceles triangle that is right-angled and has a right angle in it, or a scalene triangle that has a right angle in it. We're going to see right-angled triangles much later on. They are useful for something, otherwise we wouldn't bother mentioning them. But it's worth bearing in mind what they are now, since we're talking about triangles. Now, there are other shapes we need to be aware of as well. So we've just seen triangles. Now, triangles are 3-sided shapes. We also have a type of shape called a quadrilateral. Now, a quadrilateral is a fancy name for a 4-sided shape, and we've already seen 2 of them. We have seen a square, which had 4 sides, and a rectangle, which had 4 sides, and they are both examples of quadrilaterals. But there are 4 more quadrilaterals that we need to know. And the first of these is called a rhombus. Now, a rhombus has 4 sides, and those 4 sides are the same length. But of particular note, in a rhombus, the opposite sides are parallel. So the top and bottom are parallel, and I've marked those with a single arrow. The left and right are parallel, and I've marked those with double arrows. So 2 pairs of parallel sides. If you look closely at a rhombus, it should seem familiar. The fact that it's got 4 sides and those 4 sides are the same length should remind us of a square. And actually, if you want to think of a rhombus as a bit like a square that's been tilted, then you are welcome to. A rhombus is a little bit like a tilted square. 4 sides, all the same length, and the opposite sides are not just the same length, but parallel. We look at a rhombus, we should be able to pick out some lines of symmetry. Well, just the 2 diagonals this time, so 2 lines of symmetry. And we've also got rotational symmetry order 2, once when it's upside down and once when it's back where it started. But a rhombus, a little bit like a square that somebody has tipped over slightly. Now, very similar to a rhombus, if a rhombus is a tilted square, we also have a parallelogram. And a parallelogram is a little bit like a tilted rectangle. So it has 4 sides. 2 pairs of sides the same length, so the top and bottom are the same length, the left and right are the same length, and once again, the opposite sides are parallel, hence the name parallelogram. So the top and the bottom are marked with single arrows because they are parallel to each other, and the left and right are marked with double arrows because they are parallel to each other. And again, top and bottom are the same length, left and right are the same length. Lines of symmetry. There aren't any, it turns out, in the parallelogram. Rotational symmetry, order 2, same as the rhombus, because we'll have once when it's upside down and once when it's back where it started. Rhombus and parallelogram, both quite important. Parallelogram in particular will turn up in these angled questions quite a lot, so it's worth being aware of what they are. If you are asked to name any of these shapes, this is particularly true of rhombus and parallelogram, you are never being asked to spell correctly. You are never being tested on your spelling, as long as the word you've written is close enough to rhombus or parallelogram. If you are struggling with the spelling of those two words, or any of the words in this, of course, as long as what you've written is close enough to those for somebody to tell, then it's fine. The third of these extra quadrilaterals we need to know, these extra four-sided shapes, is called the trapezium. Now, a trapezium has four sides, which is not surprising because it's a quadrilateral. It has one pair of parallel sides and two sides that do something else. There are two examples of trapezia on the screen there. We've got the first one, top and bottom are parallel, and then two sloping sides. And then we've got also the second example, top and bottom are parallel, one vertical side, one sloping side. Well, we've got two sloping sides. They might slope in the same direction at the same angle, but they might not. They could slope differently. But a trapezium, four sides, one pair of them are parallel, for example, top and bottom, and then the other two do something else. They will either be one vertical, one sloping, or two that slope, but they might slope differently. And the final one we need to be aware of is the kite. Now, a kite has four sides, and it has two pairs of sides the same length. So two short sides at the top, marked with single dashes, two long sides at the bottom, marked with double dashes. And with a kite, it's also worth bearing in mind that there is one line of symmetry from top to bottom there. The kite is probably the easiest one to remember because it looks like a kite. So we've just seen that triangles have three sides and quadrilaterals have four sides. Quad, remember, as a word, if you think about something like a quad bike, has four wheels. So quad means four. If tri means three, quad means four. And we've seen some of these kind of naming conventions with numbers before. You also need to know a little bit about shapes that have more than four sides. In particular, the pentagon has five sides, the hexagon has six, the heptagon has seven, the octagon has eight, the nonagon has nine, and the decagon has 10. Because dec, it turns out, means 10, which is why decimals are called decimals, because it's all to do with tens. The collective name for all these shapes, so that's triangles, quadrilaterals, and then pentagons upwards, is polygons. And in fact, polygons, poly means many and gon means sides. So polygon literally means many sides, which is just a really fancy way of saying shapes. Things that have sides, shapes. So just to make this really clear, a triangle is a three-sided polygon. A quadrilateral is a four-sided polygon. A pentagon is the name for a five-sided polygon, and so on. Polygons is the collective name for shapes, fancy word for shapes, and then there are different types of those. And then within those types, there are different types of those. So three-sided polygons are triangles, and then there are different types of triangle. Four-sided polygons are quadrilaterals, and then there are different types of quadrilateral. Final thing we need to be aware of with shapes, and this is something called regular shapes. Now, a shape is said to be regular if all the sides are the same length. If all the sides are the same length, then it also must be true that the angles on the inside of the shape will all be the same size. We've already seen some regular shapes. We've seen some examples. In particular, a square is regular because all four sides of a square are the same size and all the angles are the same size. An equilateral triangle, for example, is regular. Any shape that is not regular is said to be irregular. So if we have a look at these two shapes here, they both have five sides, which means they are both pentagons. The first one, the one on the left, well, all five sides of that pentagon are the same length, and all five of the angles inside are the same size, so that is a regular pentagon, whereas the other one is an irregular pentagon, because while it has five sides, they're all different lengths. It can't be regular, therefore it must be irregular.